From the outside, we could modify the inside. Could we give messages to the inside? But the beauty is that now we are not using electrodes. Any function in the brain, emotions, intellect, personality, well, could be perhaps modified by this non-invasive technology.
They didn't have to install anything in the brain?
No, they did not. But this was the key step. This is the step where I think your audience, people find it incredulous when I tell them. The next step was, could you do this using light and light alone? And it turns out they found out you could.
This is the scientist who invented a device so radical. Some call him the mad scientist behind the CIA's most dangerous secret. His story didn't end in 1970. In fact, it still affects you right now, along with almost everyone else on this planet, and no one is talking about it. While digging deeper, I came across a neurosurgeon who dared to speak about it, but he was silenced for revealing too much. Before I show you that interview, let's go back to where it all began. In 1960, Jose Delgado shocked the world with a single demonstration. In a bull ring in Cordoba, Spain, he stepped out holding a small radio transmitter. A fighting bull charged straight toward him, but with one press of a button, Delgado stopped the animal in its tracks. The bull froze, its aggression instantly switched off by remote control. The image of a scientist taming raw animal instinct with nothing but a signal made headlines across the globe.
After the bull had recovered from the implantation and in mid-charge, the button was pressed. The bull's aggression ceased instantly, or so it seemed. A clearer experiment was performed with cats. In this classic example, the hypothalamus, the rhythm maker, was implanted with electrodes. Could it be responsible not just for rhythms, but also for rage? The switch is turned. Then the switch is turned off. So indeed, the hypothalamus does control certain types of aggression.
The device was called a stimoceiver. It was a small implant connected directly to the brain, capable of recording activity and delivering targeted electrical stimulation. With this tool, Delgado showed that emotions and behavior were not fixed. They could be interrupted, redirected, or even created by technology. What the newspapers didn't reveal at the time was that Delgado had also tested this on people. In hospitals, patients with epilepsy or psychiatric conditions received electrodes surgically implanted into their brains. Electrodes were implanted in people undergoing treatment for epilepsy or psychiatric disorders. With electrical stimulation, Delgado could trigger precise responses. A brief pulse to the motor cortex forced involuntary movement, a hand closing into a fist, an arm lifting without the patient's intention. Other regions produced emotions, sudden bursts of anger, deep relaxation, anxiety, or even uncontrollable laughter. Delgado argued that these experiments revealed a fundamental truth. The brain could be influenced like a machine, with switches for mood and behavior. During the same years, the CIA was secretly running MKUltra, a vast program on behavior modification. Declassified files later confirmed that they explored hypnosis, LSD, sensory deprivation, and electronic brain stimulation. Some of the research was disguised as academic grants, funneled through universities and hospitals, without the scientists ever knowing the real source of funding. Placed against this backdrop, Delgado's stimoceiver no longer looked like a purely medical device. To the public, it was a scientific breakthrough. To intelligence agencies, it was proof that the human brain could be mapped, triggered, and potentially controlled. Delgado himself wrote that humanity must move from the passive observation of the mind to the active creation of new mental functions. He saw progress. Others saw a dangerous blueprint, not just for curing illness, but for controlling thought itself. While digging deeper, I came across a neurosurgeon who dared to speak about it. Dr. Jack Kruse, the controversial brain surgeon I mentioned at the beginning, has pointed out
So they said, okay, you could do it with wired technology, and they were able to turn the bull off as soon as he was going to spear the matador. They said, let's try to do this wireless. Why? They had all the patents and everything they stole from Tesla. They also had all Marconi's work. At this same time, remember, Motorola is now one of the guys that's the industrial military company. They know that wireless telephony is actually coming. So they decide to employ it here first. So Delgado finds out that actually it does work. You can do it without wires. You don't have to do brain surgery on the animal to do it. And then they asked the next question.
They didn't have to install anything in the brain?
No, they did not. But this was the key step. This is the step where I think your audience, people find it incredulous when I tell them the next step was, could you do this using light and light alone? And it turns out they found out you could.
well, now it gets very interesting. Please pay attention to this display. If we look closer, every image you see on a screen, whether it's your TV, your laptop, or the phone in your hand, is built from 3 tiny lights: red, green, and blue. That tiny blue pixel is very important in today's world. Around 2005, Carl Diceroth at Stanford and Ed Boyden at MIT pioneered a method where they inserted light-sensitive proteins, called opsins, into specific neurons. Once those neurons were engineered to respond, a pulse of blue light could instantly activate or silence them with millisecond precision.
So that's the essence of optogenetics. We introduce light sensitivity into particular kinds of cells by giving them a gene.
What has this ability to control individual brain cells taught us about more complex behaviors?
We've been progressing in the complexity of the sorts of behaviors we're looking at. We started with very simple things, sleep-wake transitions. Now we're looking, as you say, at social behaviors, and we can actually turn on or off sociability by playing in particular patterns of light.
The results were shocking. In one experiment, mice froze in fear the moment the light hit, and then resumed calm behavior the instant it was turned off. In another, researchers triggered compulsive actions, a mouse pressing a lever over and over, driven not by instinct, but by an artificial flash in its brain. It's important to understand what this means. Delgado needed wires, implants, and a visible transmitter. Optogenetics replaced that with something cleaner, a beam of light. The principle is the same, external control of internal states, but the execution is far more precise. The official applications are noble. Scientists hope to treat Parkinson's disease, depression, even blindness by fine-tuning faulty brain circuits. And indeed, DARPA and the NIH have poured funding into these projects. But as history reminds us, especially with MKUltra, lines between medicine and manipulation can blur.
Can we say that by stimulating 1-2 cells, we can manipulate behavior, for example?
Yeah, so probably at this point, thousands of studies have been done where people will activate or silence a set of cells, or sometimes even one cell, and you can see changes in behavior. So you can study sensation, you can drive one or more cells and see if an animal will respond to it.
So here we are. Delgado's button has become a laser. What began as crude experiments in the 1960s is now a laboratory reality, with the potential to reshape human behavior at its most fundamental level. But this is also where the shadow of history returns, because while neuroscientists celebrate breakthroughs, others see echoes of something Delgado began decades earlier, and of what agencies like the CIA once explored through MKUltra.
If you use blue light specifically, it actually destroys the dopamine reward tracks in your brain. Just so you know, Meta and Google today own those patents. They basically then figure out and perfect the delivery of blue light technology through screens. Who is the big tech company in the 1950s and 60s that were doing this? Turns out that's IBM. And IBM is working on liquid crystalline displays. And I remember, this is in the 50s and 60s. You as a young man never saw those TVs until the 90s. Okay? And then it got a boost from who? Obama, who made the analog to digital transition so that you'd have to use what? LCD screens. And then what else did he do? We're going to ban incandescent bulbs. Why? Because incandescent bulbs not only have fake blue light, but they also have purple and red, which is what you need as the antidote to blue.
Today, almost everyone is in contact with it daily. Every person, everywhere, exposed to the very wavelength of light that modern neuroscience uses to alter the behavior of animals. Incandescent bulbs, the classic glass lamps with glowing filaments, were banned across much of the world starting in the late 2000s. The official reason was efficiency. They consumed too much energy compared to compact fluorescents and LEDs. But what Cruz points out is that incandescent light contained a wide spectrum, including infrared, a wavelength linked to cellular repair and healthy mitochondrial function. When they disappeared, that spectrum vanished from everyday life. Televisions followed a similar path. For decades, CRTs, cathode ray tube televisions, filled living rooms. Heavy, bulky, and outdated, they eventually stopped being manufactured. By the mid-2000s, they were replaced almost entirely by flat-panel LCD and LED screens. On the surface, it looked like progress: slimmer design, sharper images, lower power use. But the light source was different. CRTs had a spectrum closer to natural light, while modern LED screens concentrate on blue wavelengths. Cruz explains that incandescent bulbs and CRT televisions, while dismissed as outdated, actually produced a full spectrum of light, including infrared, which balanced and protected our biology. The global switch to LEDs stripped away that balance, leaving only harsh blue wavelengths that disrupt the brain's chemistry. Every screen acts like a signal, pulling the brain into a cycle of stimulation and reward. Blue light excites retinal cells, creating a direct signal to the brain's reward system. The constant flicker and saturated colors amplify dopamine release, locking attention. That's why even an infant, only a few months old, will stare transfixed at a glowing television or phone. The light is unnaturally intense compared to anything in the natural world, and the brain is wired to respond.
You probably remember when you were a little kid, you touched an incandescent bulb, it's hot as shit. The proxy that they're using to you is, oh, well, they burn too much energy because they have UV light and red light in it, and that makes heat. So therefore, we should get rid of that, do blue. But you have no idea that DARPA already want blue light everywhere so they can control you with it. That's the real answer behind this whole program.
Well, now it gets even more disturbing. After I did some research on this topic, I found something that connects directly to what we've been building toward. Declassified military reports reveal that light itself has been tested as a weapon. Not in science fiction, but in official Pentagon and DARPA programs. During the 1990s and early 2000s, U.S. defense agencies openly funded research into what they called non-lethal directed energy weapons. Among them were devices based on light. Lasers known as dazzlers were deployed in Iraq, capable of temporarily blinding and disorienting people at a distance. Stroboscopic lights, flashing at carefully chosen frequencies, were also studied as tools for crowd control, exploiting how the human brain responds to intense rhythmic visual input.
U.S. officials say there are now 130 suspected victims, mostly CIA operatives and U.S. diplomats being treated for brain injuries, debilitating headaches, and vertigo, the targets they believe of a directed energy microwave weapon.
There's a mysterious direct energy weapon that is being used, and it is causing, in some cases, permanent traumatic brain injury.
What makes this unsettling is not the existence of the technology, but the biological fact behind it. Our nervous system is tuned to light. Change the frequency, intensity, or pattern, and you can induce confusion, headaches, nausea, even seizures. This is not speculation. In 1997, a Pokemon TV episode in Japan triggered seizures in over 600 children due to strobing red and blue lights. If a cartoon could have that effect accidentally, what could engineered systems do deliberately? Declassified DARPA documents from the mid-2000s described neurological research into how light, sound, and other forms of energy could be combined for behavioral influence. Officially, the goal was non-lethal crowd management, but the language is vague enough that some researchers question whether the line between defense and manipulation was blurred. The parallel becomes impossible to ignore. Jose Delgado once pressed a button and made a bull stop mid-charge. Decades later, defense agencies explored pushing crowds with pulses of light. Different methods, same underlying principle. External control over internal states. Everything you've just seen is the result of hours of research, piecing together fragments, documents, and testimonies. I'm not here to tell you what to believe. My role is just to connect the dots and present the story. The real conclusions are yours to make. If you found this valuable, please support the channel with a like and subscribe. It means a lot and helps us keep going. Thank you.